Okay guys, welcome back, Altree and Trig. We're going into section 1.4. Our goal today is to write equations of lines. You have seen this section, this topic in Algebra 1 and Algebra 2. Now you're going to see it for a third time. So if it hasn't clicked before, it should click this time, hopefully. So our goal again is to write equations of the lines in, our end goal will be slope-intercept form. Instead of y equals mx plus b, we're going to do f of x equals mx plus b. We're going to be using function notation, in other words. All right, f instead of y equals, we'll use f of x equals, or g of x equals, or h of x equals, etc. So, on a previous day, I did share an ed puzzle with you guys on point-slope equation. Hopefully you watched that. If you did not, please stop this video and go back and watch it, or else today's going to be a little bit rougher. All right, if you know the slope of a line and the coordinates of one point on the line, you can use the point-slope equation to write the equation of the line. And we're going to be using two formulas here today. We're going to be using the slope formula, m equals, subtract the y's on top, and subtract the x's on the bottom, and then simplify. And once we have a point and a slope, we are going to use the point slope formula here, which is m, of course, is the slope, and the x1, y1 are coordinates of a point that it would pass through. Okay, so let's take a look here. Now, in the past, you didn't have to do these problems in function notation. It would just say, here's a point and here's a point, write an equation of a line. Now, in this class, in Algebra 3, it's given in a fancier notation, function notation. So we're going to write, first it says, find a linear function h, given h of 2 equals 3 and h of 1 equals -4. Let me stop you right there. And before I go on further, these are actually 2 points. So these are the 2 points that we're going to be using. It says, then find h of 5. Well, what that means is find out, get me an output when the input x is 5. That'll be for later. The h of 5 will be for later after we get an equation. So let's focus on these 2 points that I just wrote in green. As the goal here is to write a linear function, we do need a slope, so that's going to come in first. So slope is y2 minus y1 divided by x2 minus x1. So subtract, and then divide. So our slope is 7. So after that, we're going to use the point slope equation. Of course, this will be my x1, y1, and my slope m is 7. So y minus y1 equals m parentheses x minus x1. And we're now going to turn this into a slope-intercept form, y equals mx plus b. We're going to distribute the 7. And then get y by itself. We're going to add 3. Now that's the equation. We're going to write it. It does want a linear function h. So that means instead of y equals, we replace the y with h of x equals 7x minus 11. So there is our linear function h of x. All right, so that's part 1. Now part 2 is this, then find h of 5. So we're going to use our h of x equals that I have highlighted there. And we're just plugging in the 5 for the x's. So 7 times 5 minus 11. 7 times 5 is 35. minus 11 is 24. So h of 5 equals 24. So there's my two parts for the problem. I have my linear function h of x, and I have my h of 5, which is 24. Okay, let me fast forward a little bit. I don't want to do parallel lines or perpendicular. I want to do another one where it says independent practice on the next page. So I'm going to do another one like it. It's going to be the same routines. So here are my 2 points, my x1, y1. There's my first point. There's my second point. So I'm going to need to write a linear function h. So I'm going to go through my steps that I just did. First is get the slope. So y2 minus y1 over x2 minus x1. In the numerator, those subtract to get negative 12. In the denominator, we got double negatives. Changes to negative 1 plus 3 is 2. And that divides to get negative 6. So my slope is negative 6. So now I'm going to go into, we could always look back what I do next. I did my point slope formula. So y minus y1 equals m parentheses x minus x1. Now those double negatives, change that to a plus 3 right away. We're going to distribute the negative 6. We're turning it into slope-intercept form now. Distribute the negative 6 to have negative 6x minus 18. Then we're going to add 7. So we have y equals negative 6x minus 11. So that is my equation. Now we're going to turn it into, it says write a linear function h. So instead of y equals, we're going to change it to h of x equals negative 6x minus 11. So there's my linear function h. Now let's do the follow-up. Then find h of 2. So I'm going to take my function, plug 2 in for x. Negative 6 times 2 minus 11. That'll be negative 12 minus 11 is negative 23. So h of 2 is negative 23. And that is done. Okay, let's go back up. Now, parallel lines. We're going to be, in this next part, we're still having our main goal being write equations of lines, but we're going to be talking about parallel and perpendicular lines. So parallel lines, remember, have the same slope. The slope of one is the same as the slope of another. That's what it means by m1 equals m sub 2. So example 2, let's read these directions. Write a linear function f that is parallel to g. Now g's function is negative 3/4 x minus 5. Given that f of 4 equals 8. Well, let's break this down. Remember, to have an equation, we need a slope and a point. Your point is the 4, 8. That's going to be your x1 is 4, y1 is 8. Your slope you're going to get from this function g of x. The slope here is negative 3/4. Remember, the slope is always in front of the x. Parallel to negative 3/4 is negative 3/4. They're identical. So that slope, that's negative 3/4 is what I'm going to use for my m. So I'm going to go into my point slope formula now that I have a point and a slope. So y minus y1 equals m parentheses x minus x1. And now I'm going to convert this over to slope-intercept form. I'm going to distribute the -3 force. Over 4 is 3. And then add 8 to get y by itself. And then it says y equals, it does say back here, write a linear function f. So I'm going to change it to f of x equals -3/4 x plus 11. And then I double check my directions, write a linear function f. I did that, and there's no follow-up to it. So that's it. I'm done there. Okay, let's go try another parallel one. Letter B on the next page, write a linear function f that is parallel to g of x equals 2x plus 9, given that f of -1 equals 6. Again, I need a point and a slope. My point is right here, x1, y1. My slope I get from g of x. What is the slope in g of x? You should be thinking it's the 2. And since it says parallel, so that means it is equal to the 2. So that's what I'm going to use in my point slope formula, which I'm going to go into right now. Y minus y1 equals m parentheses x minus x1. Those double negatives, let's change to a plus, so it's x plus 1. And let's convert this to slope-intercept. Distribute the 2, get rid of parentheses. Then we're going to add 6 to the 2. And there it is in slope-intercept form, but we're going to make one final adjustment. Our goal is to write a linear function f, so no y equals. You got to write f of x equals 2x plus 8. So that's it for parallel lines. Remember, when it says parallel, you're looking at the equation it gives you, and you're taking that exact slope. Now, perpendicular is going to be different. Perpendicular lines have opposite reciprocal slopes. And when you multiply reciprocal slopes, or perpendicular slopes, it gets -1. Not that that's important. It's really not an important question. What that means is when you're dealing with opposite reciprocal, that means you change the sign and you flip it upside down. Let me show you some examples on the side before I move on. So say if I have a slope of 5/3 or 3/5. Perpendicular to that is -5/3. We change the sign and flip it upside down. So if I had -7, what would perpendicular to -7 be? +1/7. Let's -1/3. What would be perpendicular to that? +3/1, which is 3. And what about 1? What's perpendicular to 1? It would actually be -1. 1 upside down is still 1, and of course change the sign. So there's some examples of perpendicular lines as a referral point for you. So example 3, our goal is to write a linear function f that is perpendicular to g of x equals 5x minus 3, given that f of 10 equals 12. So we're going to pretty much go through the same exact procedure using point slope formula. Now my point, 10 is x1, 12 is y1, and then my slope, I look at function g. What's your slope in g? Your slope in function g is 5. But we don't want to use the 5 because it says perpendicular. That means we have to change it. So we must use what is perpendicular to 5. Refer back here if you need help. It would be -1/5. So that's our slope we're going to be using in our point slope formula. So now we're going to go ahead and go to our point slope formula. Y minus y1 equals m parentheses x minus x1. Now we're going to convert this over to slope-intercept form. We're going to get rid of the parentheses. We're going to distribute negative 1/5. Negative times negative is a plus. 1/5 times 10. 10 over 5 is 2. Then we're going to add 12. And we got y equals negative 1/5 x plus 14. And then looking back, it does say write a linear function f, so we don't want y equals, we want f of x equals. And there's our answer. There is our function f that is perpendicular to function g. So please remember, when it uses the word perpendicular, you gotta change the slope. All right, let's try one more, then I'll let you guys on your own. Letter C. So write a linear function f that is perpendicular to g of x equals negative 2x minus 4, given that f of negative 4 equals negative 5. So negative 4 is x1, negative 5 is y1. What's your slope in function g? Your slope in function g is negative 2, but it says perpendicular, so what's perpendicular to negative 2? It would be positive 1/2, or 1/2. So now we're going to go to our point slope formula. Y minus y1. Let's change those double negatives to a plus. Equals m parentheses x minus x1. Let's also change those double negatives to a plus. And now we're going to convert to slope-intercepts. We're going to get rid of the parentheses, distribute the 1/2. So 1/2 times x, and 1/2 times 4 is 2. Then subtract 5. So there is our slope-intercept form. One final thing, we need to write a linear function f. So f of x instead of y. And then there's your answer. Okay, guys, we're all done. I would suggest, when looking back, please make sure, I feel that it would be best for you to memorize the point slope equation. It'll make your life easier in the long run. All right, guys, good luck.